Every single day, fishing fleets across the globe catch over 20 million pounds of sardines. That's enough small fish to fill more than 4,000 pickup trucks, and it happens every 24 hours without fail. But here's what will shock you. 90% of these sardines are caught using methods so precise and efficient that entire schools of fish can be harvested in under 30 minutes. How do massive fishing vessels locate and capture billions of these tiny silver fish from the vast ocean? What happens inside the industrial processing plants that transform raw sardines into the canned products found in grocery stores worldwide? And why has this humble fish become one of the most important protein sources for 3 billion people around the planet? Welcome to AgriCraft, where we explore the incredible technologies and processes behind the world's most essential food production systems. I'm your host, and today we're diving deep into the extraordinary world of industrial sardine fishing and processing, where cutting-edge marine technology meets massive-scale food manufacturing. From the moment sonar systems detect sardine schools in the open ocean to the final automated packaging that sends millions of cans to global markets, all will be revealed in this video. The sardine industry represents one of the most remarkable success stories in modern food production, combining advanced fishing technology with sophisticated processing systems that can handle millions of fish per day. These operations require precision timing, massive logistical coordination, and quality control standards that ensure safe, nutritious food reaches consumers across 6 continents. The scale is almost incomprehensible, with individual processing plants capable of producing over 1 million cans in a single 8-hour shift. Sardines belong to the herring family and have been sustaining human populations for thousands of years. Archaeological evidence from coastal settlements around the Mediterranean Sea shows that ancient civilizations developed specialized nets and preservation techniques specifically for sardine fishing over 4,000 years ago. The name sardine actually comes from the Italian island of Sardinia, where massive seasonal runs of these fish supported entire communities through sophisticated fishing and preservation methods. The transition from traditional small-scale fishing to modern industrial operations began in the early 1900s when steam-powered vessels and mechanized nets revolutionized the industry. The invention of seine nets in the 1860s provided the foundation for today's massive harvesting operations, but it was the development of fish-finding sonar in the 1940s that truly transformed sardine fishing into the high-tech operation we see today. Global sardine production now exceeds 6 million tons annually, making it one of the most harvested fish species on Earth. The industry is worth over $12 billion worldwide, with major fishing operations in Peru, Chile, Morocco, South Africa, Japan, and along the Pacific coast of the United States. Peru alone accounts for nearly 40% of global sardine production, with their anchovy and sardine fisheries supporting over 200,000 jobs directly and indirectly. But what makes sardines so commercially valuable goes far beyond their use as human food. These small fish serve as the foundation for massive aquaculture operations worldwide, with processed sardine meal feeding farmed salmon, shrimp, and other high-value seafood. The global feed industry consumes over 60% of all sardines caught, making this fishery absolutely critical for modern food security and the growing aquaculture sector. The biological characteristics that make sardines ideal for industrial fishing include their schooling behavior, predictable migration patterns, and rapid reproduction rates. Sardines form dense schools that can contain millions of individual fish swimming in perfect synchronization. These schools can stretch for several miles and reach depths of over 200 feet, creating massive concentrations of biomass that modern fishing technology can locate and harvest with remarkable efficiency. Sardine populations are closely tied to ocean temperature cycles and nutrient availability, creating seasonal patterns that experienced fishing operations have learned to predict and exploit. The California Current System, the Humboldt Current off South America, and the Benguela Current off Africa all support massive sardine populations during specific times of the year. Understanding these patterns is crucial for the timing of fishing operations and the scheduling of processing plant capacity. The life cycle of sardines makes them particularly well suited for sustainable harvesting when properly managed. Most sardine species reach sexual maturity within their first year and can produce thousands of eggs during spawning season. This rapid reproduction allows populations to recover quickly from harvesting pressure, but it also means that fishing timing must be carefully coordinated to avoid disrupting spawning cycles that maintain future populations. Modern sardine fishing operations begin with sophisticated fish-finding technology that can locate schools from miles away. Sonar systems on fishing vessels use sound waves to map the ocean floor and identify the distinctive signatures of sardine schools. Advanced sonar can distinguish between different fish species based on swim bladder characteristics and schooling patterns, allowing fishing crews to target specific species and avoid bycatch of non-target fish. Satellite technology plays an increasingly important role in modern sardine fishing operations. Ocean temperature mapping, chlorophyll concentration data, and current information help fishing fleets predict where sardine schools are most likely to be found. This data-driven approach reduces fuel consumption, increases catch efficiency, and minimizes environmental impact by reducing the time vessels spend searching for fish. The primary fishing method for sardines is purse seining, a technique that involves surrounding entire schools with massive nets that can be over half a mile long and 300 feet deep. Modern purse seine nets are marvels of engineering, constructed from high-strength synthetic materials that can withstand the enormous forces created when thousands of tons of fish are concentrated in a small area. The nets include sophisticated sensor systems that monitor fish behavior and net integrity throughout the fishing process. Purse seine operations require precise coordination between multiple vessels and can involve crews of over 30 experienced fishermen. The process begins when spotter aircraft or drones locate sardine schools and relay GPS coordinates to fishing vessels. Once a school is located, the fishing vessel deploys its net in a wide circle around the entire school, with the net wall extending deep enough to prevent fish from escaping underneath. The seining process itself is a carefully choreographed operation that must be completed quickly to prevent sardines from detecting the net and attempting to escape. Modern vessels can deploy and close a purse seine net around a sardine school in under 20 minutes, capturing everything within the enclosed area. Hydraulic winches and automated net handling systems manage the enormous forces involved in closing and retrieving nets that may contain hundreds of tons of fish. Once the net is closed, pumping systems transfer sardines from the net directly into the vessel's refrigerated holds. These pumping systems use gentle suction to move fish without damaging them, maintaining quality throughout the harvesting process. Modern fishing vessels can process over 15 tons of sardines per minute through their pumping systems, allowing rapid harvest of even the largest schools. The onboard storage systems on sardine fishing vessels are designed to maintain fish quality from the moment of capture until delivery to processing plants. Refrigerated seawater systems keep sardines at optimal temperatures while preventing the bacterial growth that can rapidly degrade fish quality. Some vessels use controlled atmosphere storage that adjusts oxygen and carbon dioxide levels to extend fish freshness during longer fishing trips. Transportation from fishing grounds to processing plants requires careful timing and logistics coordination because sardines must be processed within hours of harvesting to maintain optimal quality. Many fishing operations use refrigerated transport vessels that can maintain sardines in perfect condition for up to 5 days, allowing fishing fleets to operate in distant waters while ensuring product quality upon arrival at processing facilities. The scale of sardine harvesting operations is truly staggering when you consider that a single purse seine set can capture over 2,000 tons of fish in one operation. Large fishing vessels can harvest up to 5,000 tons of sardines per day when conditions are optimal, requiring massive logistical support systems to handle, store, and transport such enormous quantities of fish. At the processing plant, sardines undergo immediate quality inspection by trained technicians who evaluate freshness, size distribution, and overall condition. This initial assessment determines the processing pathway, with premium quality sardines destined for human consumption markets, while lower grade fish may be processed into fish meal or other products. The grading process uses both visual inspection and technological systems that can evaluate fish quality parameters in real time. The primary processing stage begins with automated systems that wash sardines in chlorinated seawater to remove surface bacteria and debris. Industrial machines handle thousands of sardines per minute using gentle spray systems and rotating drums that clean fish without damaging delicate skin and scales. Water temperature during washing is carefully controlled to maintain fish quality while ensuring effective cleaning. Size sorting represents a critical step in sardine processing because different market applications require specific size ranges. Automated sorting systems use optical sensors and mechanical graders that separate sardines into precise size categories. These systems can process over 10 tons of fish per hour while maintaining accuracy levels that exceed 99%. Computer-controlled conveyor belts direct sardines to appropriate processing lines based on their size classification. The main industrial processing steps vary significantly depending on the intended final product, but most operations begin with heading and gutting processes that prepare sardines for canning or other preservation methods. Modern processing equipment can handle over 100 sardines per minute, using precision cutting systems that remove heads and internal organs while maintaining the integrity of the fish body. For canned sardine production, automated systems arrange prepared sardines in cans with mathematical precision that maximizes product yield while maintaining visual appeal. Industrial machines can fill over 500 cans per minute, using weight-based controls that ensure consistent product portions and optical systems that verify proper fish arrangement within each can. The canning process itself involves adding various liquids such as oil, tomato sauce, or brine, depending on market preferences and product specifications. Automated filling systems precisely measure liquid additions while maintaining sanitary conditions throughout the process. Temperature control during filling is critical to prevent bacterial contamination and ensure proper product preservation. Sealing operations use high-speed seamers that create hermetic seals on thousands of cans per hour. These machines apply precise pressure and heat to create seals that will maintain product integrity for years under proper storage conditions. Quality control systems continuously monitor seal integrity using both mechanical testing and random sampling protocols that detect any defects before products leave the processing plant. The sterilization process represents one of the most critical stages in sardine canning operations. Industrial machines called retorts use precise combinations of heat, pressure, and time to eliminate all harmful bacteria while preserving nutritional value and taste characteristics. Modern retort systems can process thousands of cans simultaneously while maintaining exact temperature and pressure profiles that ensure both safety and quality. Temperature control throughout the sterilization process requires sophisticated monitoring systems that track internal can temperatures using mathematical models and sensor technology. The process typically involves heating sealed cans to temperatures exceeding 240 degrees Fahrenheit for specific time periods that vary based on can size and product formulation. This sterilization process eliminates the risk of botulism and other foodborne illnesses while extending shelf life to several years. Cooling systems rapidly reduce temperatures following sterilization using controlled water sprays and air circulation systems. The cooling process must be carefully managed to prevent can damage while ensuring that internal temperatures reach safe levels quickly. Industrial machines can cool thousands of cans per hour while maintaining precise temperature control that prevents overcooking and preserves product quality. Quality inspection following sterilization involves multiple testing protocols that verify both safety and quality parameters. Random sampling programs test for bacterial contamination, seal integrity, and product consistency. Advanced testing equipment can detect minute traces of spoilage bacteria and ensure that every can meets safety standards before labeling and packaging operations begin. Labeling operations use high-speed printing and application systems that can process over 10,000 cans per hour while maintaining perfect label alignment and print quality. Modern labeling systems include vision inspection technology that verifies label placement and print quality on every single can. Automated systems can apply multiple labels, date codes, and regulatory information while maintaining production speeds that match the output of processing lines. Packaging systems for canned sardines accommodate various market requirements, from individual consumer cans to bulk packaging for food service operations. Automated packaging equipment arranges cans in cases, applies shrink wrapping, and prepares products for distribution. These systems can package over 5,000 cans per hour while maintaining consistent case weights and proper product protection. Cold storage facilities at sardine processing plants use sophisticated refrigeration systems that maintain optimal temperatures for different product types. While canned sardines don't require refrigeration, many processing plants also produce fresh and frozen sardine products that demand precise temperature control. Automated storage systems can handle millions of cans while tracking inventory levels and rotation schedules that ensure first-in, first-out distribution practices. Distribution networks for processed sardines involve complex logistics systems that coordinate global shipping schedules with production planning and inventory management. The The sardine industry supplies markets on every continent, requiring specialized transportation systems that can maintain product quality during extended shipping periods. Containerized shipping systems allow efficient transport of millions of cans while protecting products from damage and contamination. Export operations require extensive documentation and quality certification that meets importing country requirements. Processing plants maintain detailed records of every production batch, including raw material sources, processing parameters, and quality test results. This traceability system enables rapid response to any quality issues and ensures compliance with international food safety regulations. The domestic market for sardines includes both retail and food service channels that require different packaging formats and distribution methods. Food service operations often purchase sardines in larger containers that reduce packaging costs and improve handling efficiency. Retail markets demand attractive packaging and convenient sizes that appeal to consumers while maintaining competitive pricing. Value-added sardine products represent growing market segments that command premium prices and higher profit margins. Smoked sardines, sardines and specialty sauces, and ready-to-eat sardine products require additional processing steps and more sophisticated packaging systems. These products often undergo additional quality inspection procedures and require specialized storage and distribution methods. The byproducts from sardine processing create significant additional revenue streams that improve overall industry economics. Sardine meal produced from fish heads, bones, and processing waste serves as a high-protein ingredient in aquaculture feeds and pet foods. Fish oil extracted during processing has applications in dietary supplements, pharmaceuticals, and industrial products. Sardine oil is particularly valuable because of its high omega-3 fatty acid content, which makes it ideal for dietary supplement applications. Modern processing plants use sophisticated extraction and purification systems that can recover over 90% of available oil while maintaining the nutritional properties that make sardine oil valuable for human health applications. Fish meal production involves cooking and pressing operations that remove moisture and concentrate protein content to levels exceeding 60%. Industrial machines can process hundreds of tons of sardine waste per day, converting what was once discarded material into valuable protein sources for animal feeds. The fish meal market represents over $2 billion in annual sales globally, making byproduct recovery a critical component of sardine processing economics. From a culinary perspective, sardines offer remarkable versatility and nutritional density that makes them valuable for both developed and developing nation food security. Fresh sardines can be grilled, fried, or baked, while canned sardines provide convenient protein sources that require no refrigeration. Mediterranean cuisines have developed hundreds of traditional sardine preparations that showcase the fish's flavor and nutritional benefits. The nutritional profile of sardines makes them one of the most beneficial foods available, providing high-quality protein, omega-3 fatty acids, calcium, and vitamin D in affordable, convenient forms. A typical serving of sardines provides over 20 grams of protein while delivering significant amounts of heart-healthy omega-3 fats that support cardiovascular and brain health. The calcium content in sardines with bones exceeds that of milk, making them particularly valuable for bone health in populations with limited dairy access. Sustainability considerations in sardine fishing have become increasingly important as global demand continues growing and climate change affects ocean ecosystems. Modern fishing operations use quota systems and seasonal restrictions that maintain sardine populations at sustainable levels. Scientific monitoring programs track sardine biomass and reproduction rates to ensure that harvesting levels don't exceed population replacement capacity. Environmental impact assessments of sardine fishing operations show that properly managed sardine fisheries can actually have positive environmental effects by maintaining ocean ecosystem balance. Sardines serve as key prey species for marine mammals, seabirds, and larger fish, so sustainable sardine populations support entire marine ecosystems. Responsible fishing practices ensure that these ecological relationships remain intact while providing human food security benefits. Bycatch reduction technologies in sardine fishing operations minimize the capture of non-target species through improved net design and fishing techniques. Modern purse seine nets include escape panels that allow non-target fish to escape while retaining sardines. Dolphin-safe fishing practices have been developed specifically for sardine operations to protect marine mammal populations that often associate with sardine schools. Climate change impacts on sardine populations include shifting migration patterns and changes in ocean productivity that affect fish abundance and distribution. The sardine industry has adapted to these changes through improved forecasting systems and flexible fishing operations that can adjust to changing fish distribution patterns. Research into climate-resilient fishing practices helps ensure long-term industry sustainability. Technology integration in modern sardine operations continues advancing through artificial intelligence systems that optimize fishing operations and processing efficiency. Machine learning algorithms analyze vast amounts of oceanographic data to predict sardine locations and abundance levels. These systems improve fishing success rates while reducing fuel consumption and environmental impact. Automation in sardine processing plants continues expanding with robotic systems that handle routine tasks and computer vision systems that enhance quality control capabilities. Advanced sensors monitor fish quality parameters throughout processing and packaging operations, ensuring consistent product quality while reducing labor requirements. These technological advances enable processing plants to maintain high standards while managing enormous production volumes. The economic impact of the sardine industry extends far beyond fishing and processing operations, supporting shipbuilding, equipment manufacturing, transportation, and countless related industries worldwide. Coastal communities in major sardine-producing regions depend on the industry for employment and economic development. The multiplier effects of sardine fishing create jobs in areas ranging from marine electronics to packaging materials. Research and development in sardine industry technology focuses on improving sustainability, efficiency, and product quality through innovative processing methods and fishing technologies. University research programs work closely with industry partners to develop solutions for challenges ranging from fish spoilage prevention to more efficient processing systems. These collaborations ensure that the industry continues adapting to changing market demands and environmental conditions. The integration of sardine fishing and processing operations with global food security initiatives highlights the critical role these small fish play in addressing malnutrition and protein deficiency worldwide. International development programs promote sardine consumption in regions where protein sources are limited and expensive. The affordability and nutritional density of sardines make them ideal for addressing food security challenges in developing nations. Future developments in sardine industry technology will likely include enhanced automation, improved sustainability practices, and new product innovations that expand market applications. Advances in preservation technology may enable new distribution methods that bring sardines to markets previously inaccessible due to infrastructure limitations. Innovation in processing equipment will continue improving efficiency while maintaining the quality standards that consumers demand. The remarkable transformation of sardine fishing from small-scale coastal operations to massive industrial systems demonstrates how modern technology can scale traditional food production methods to meet global demand. Today's sardine industry combines sophisticated ocean science, advanced engineering, and precise quality control to deliver billions of nutritious meals to consumers worldwide. The complete journey from detecting sardine schools in vast ocean expanses to delivering finished products to global markets showcases the incredible complexity and coordination required for modern food production. Every step involves specialized technology, skilled workers, and comprehensive quality systems that ensure safe, nutritious products reach consumers regardless of their location on the planet. The sardine industry's ability to sustainably harvest billions of fish annually while maintaining ocean ecosystem health provides a model for responsible marine resource management. The combination of scientific monitoring, technological innovation, and industry cooperation demonstrates that large-scale food production can coexist with environmental stewardship when proper management practices are implemented and maintained. Looking ahead, the sardine industry will continue evolving to meet growing global protein demand while adapting to environmental changes and technological advances. The industry's track record of innovation and adaptation suggests that sardines will remain a critical protein source for billions of people while supporting coastal economies and marine ecosystems worldwide. This incredible story of how billions of sardines journey from ocean schools to global dinner tables reveals the remarkable scale and sophistication of modern food production systems. The technology, logistics, and human expertise required to safely and efficiently process millions of these small fish daily represents one of the great achievements of industrial agriculture and marine resource management. Thank you for joining us on this fascinating exploration of the sardine industry's incredible scale and technology. If you found this deep dive into industrial fishing and processing enlightening, please give this video a thumbs up and subscribe to AgriCraft for more detailed investigations into the technologies and processes that feed our world. Let us know in the comments what aspect of food production you'd like us to explore next. And until next time, keep discovering the amazing innovations that bring food from source to table.